Okay, we are going over number 2 from the homework last night. So, pretend all you see is this equation. Your first job is to figure out who the parent function is of this. Who's the parent function? Yeah, I have an x squared in there. This is not an absolute value function or I'm not cubing anything. I'm squaring something. So the parent function is just a quadratic. Y equals x squared. So let's start by sketching the parent function. Whoa, wrong way. Okay. So remember what x squared looks like. You have your vertex at 0, 0. You go up 1. You go up 3. You'd go up 5 if you had enough. Okay, so there's the original parent function. Now, let's just break it down and see what all these pieces are going to do to everything. Okay, so what do I do with the 1/2 out in front here? Say that again? If you have a 1/2 on the outside, go ahead. You think you have something? Take a guess, somebody. Yes, the whole thing's going to shrink. I'm going to multiply all my y values by 1/2. When it's on the outside, I really do what it tells me to do. To the y's, right? So on the outside, 1/2. That means I'm going to multiply every y value by 1/2. So let's go ahead and do that. So 0 times 1/2 is still just 0, so I'm just going to stay there. But this y value is 1 times 1/2 is now 1/2. Same thing happens over here. This y value was 4, but now it's 2. So this one drops down to 2 also. Okay, so here's my new graph. So let's erase the original now. Okay, and let's check off that we handled that part of it. All right, now this 1/3 in there, what does a 1/3 in there with the x tell me to do? Say that again. You're so close. If it's in there with the x, I'm going to do it to the x, but I need to do the opposite of what it's telling me to do, right? So right now it's telling me to multiply by 1/3. I need to now instead divide by 1/3 to all the x values. And what's dividing by 1/3 really doing? Multiplying it by 3. So every x value that I have is now going to get multiplied by 3. So here is my first x value. 0 times 3 is still just 0, so it's still going to stay there. This x value is 1, but now I'm going to multiply it by 3. So instead of it being at 1, it's now going to be at 3. So this point is now way out here. Do you see that? This point went from 1, but I multiplied it by 3, so now I'm at 3. This x value is at 2, so now where is it? 6. And then the same thing happens on the other side. You were at -1, so now you're at -3. You were at -2, so now you're at -6. So we end up with an even wider graph. My goodness. That's not a very good parabola. Okay, let's get rid of this on the inside because I don't need it anymore. So now I've taken care of that. Now these next two I can do both at the same time because this is going to tell me to go to the right 3 and up 2. So let's start with the origin. I'm now going to go to the right 3 up 2. So my new vertex is right there. And then every other point that I had, so this one right here is now going to go to the right 3 up 2. And all the way around. So you're too far off my grid, but now you went right 3 up 2. Right, 1, 2, 3, 1, 2. So my final graph should look like that. Remember, if you want an eraser, I have a whole box. Yep. Yeah, so that's after we did a half and we did a third. And now I picked up each dot and I went right 3 up 2. So my vertex moved up to there. Yep. Okay, let's try 3. I mean 4, because we just did the evens. Okay. So there's your end result, but let's sort of figure out how we get there. What's the parent function this time? X cubed. Yes, I'm cubing something. So let's go ahead and sketch what that parent function looks like normally. Yeah, I can do it right here. So x cubed. Plug in 0. If I cube 0, I get out 0. If I plug in 1, what's 1 cubed? 1. If I plug in 2, it's 2 cubed. 8. So it's already off my grid, but it's helpful to just kind of know it's way up there. If I plug in -1, what is -1 cubed? -1. So this one goes this way. So if you recall, sort of a squiggle like that. Okay, so there's my parent function. Now let's go over what each piece is going to do. What is this negative outside going to do? Yes, all my y values will get multiplied by a -1. So it's going to flip over that x-axis. Okay, so 0 multiplied by -1 is still just 0. +1 multiplied by -1 is now -1. I had +8, now it'll be at -8. Same thing over here. -1 flips over here. And then this one's going to flip to a +8. So, there's that. Erase the old. Okay, so we took care of that first piece. The next 2, I can handle at the same time. This tells me to go left 2 and left 2, down 2. So that's all I got to do. Pick it up and slide it. And we will be done. Oh my gosh, thank you so much. Have a good day. Thank you too. Bye guys. Okay, so let's pick this thing up and slide it and we'll be done. And what do we say? Left 2, down 2. So there is my final graph. Is that all right? Are we feeling better about these maybe? I hope. Getting there piece by piece. All right, 6. Okay. Who is the parent function? It's that reciprocal one, right? 1 over x. So let's sketch that parent function real quick. Remember that we have asymptotes at the x and y axis. 1, 1, and then it just sort of hugs the axes like that. -1, -1, same thing over on this side. Okay, so there's my parent function. Now, let's see what's happening. Ooh, this is interesting. So there's a 2 up on top. That's different. But let me ask you, couldn't I rewrite this whole thing like this? Well, let me see if I can get it at the same time. I want to take this. Isn't another way to write that whole thing like this? Is that the same thing? Yeah. So we're used to it in this style. Right here, because I want that parent function to be 1 over x. So now it's easier, at least for me, to see that this 2 out in front, I'm really going to do what with it? multiply all my y values by 2. So that's what that's indicating for me to do. So I'm going to multiply all the y values by 2, and then I'm also going to shift it left 3, down 3. Okay? Yeah.
I didn't know if you have to multiply the y values or the x values by 2.
Okay, so remember that the parent function is y equals 1 over x, right? So if I'm going to do something to the x's, it's going to be down here with the x. So if it's out in front of the function, then I'm going to do it to the y's. I don't know if that kind of makes sense. So if it's a, like, say it's a, think about the square root function. So if I have something under the square root in there with the x, I'm doing it to x's. If it's out here, I'm doing it to the y's. Sometimes it doesn't totally matter because, like, if you had, I think we did an example a few minutes ago that was like, wasn't it this? Isn't that the same thing as this? So that negative could be down there with the x, or it could be out in front. And it actually won't matter because it has that symmetry about the origin. So it doesn't matter if I flip it this way or this way, it's the same thing. So yes, that's your general rule of thumb. If it's, think about what the parent function is, and then if the negative or the number or whatever it is under the function, whatever the function is. So if I'm looking at this squaring one, the parent function is to take whatever x is and square it. So in this case, everything inside this parenthesis is being squared. So these are things that are getting done to the x's. So that's what I need to think about, the opposite of what it really shows. This is outside the parenthesis, it's not being squared, right? Even though I know you might be thinking, well, that 1/3's outside of parenthesis, but it's not. It's in the parenthesis that's getting squared. So all of these, that 1/3 and that -3, apply to x values. This is on the outside, it is not getting squared, that applies to a y value. Same thing like this one, that's not getting squared, that's going to be a shift of my y. Okay, so we're looking here. I have this guy out in front now, so he's going to apply to a y value. That's going to be my horizontal shift. My x's are going to shift to the left 3, then I'll move the whole thing down 3. So let's take this thing. We have the parent function. I need to multiply all the y values by 2. Are my asymptotes going to change if I multiply the y values by 2? No, they don't change. They're going to stay exactly where they are. The only thing that changes is sort of the placement of these arcs, right? If I take 1, the y value is 1, I'm going to multiply it by 2. This dot just moves up here. But then it still is just going to go off, and it's still going to hug this side, and it's still, this one's just going to come down and it's still going to hug over here. It just moves that one dot. So same thing over here, just going to move to a -2. But then still go off to hug that asymptote, and you're going to go off to hug that asymptote. So just this little bit gets changed. Okay, so there's us multiplying by 2, and then all I have to do is go left 3, down 3. So I'll take those asymptotes and move them, left 3, down 3. And now, instead of my dots being at 1, 1 and -1, -1, it's really at 1, 2. So if that's my new origin, 1, 2 is now here. Let's put and here. And then I'm just going to have my arcs go through that point. So this is, oh, let's do red. And this point. So this one's going to come like that. How are we feeling? Okay-ish? Okay. All right, all right, all right. And on the back. So let's talk our way through this one. Who's the parent function? X squared. So let's sketch that real quick. Hopefully you guys are quick at sketching these now. Okay, so there's the parent function. Now, let's sort through this. This needs some work done to it to begin with. First of all, what in the world is going on with this -3 out here? You might be thinking, well, Miss Savia, don't you just multiply all your y values by -3? Do you? No, because you're not multiplying by -3. If that plus sign wasn't there and it was -3 times all that, then I would be. But it's not. I'm not multiplying by -3. So, what the heck do I do with that thing? Well, couldn't I do this? Watch this. Couldn't I, this function, this original function, couldn't I just write it this way? Put the -3 on the end? Sometimes they try to trick you. They try to catch you in their devil's snare. You won't let them. You're going to stay calm. And that's how you get out of it, right? My Harry Potter fans, you know what I'm talking about. If you're in devil's snare, you don't panic. You just relax. Or find some sunlight, right? Either way. So, that just moves to the end. And now you know exactly what to do with that -3. It's just going to shift my whole graph down 3, right? But it's so weird that when it's in front, it throws us off because it's not in the form that we're used to. So if you just have a number dangling, put it on the end. Okay. Now, I don't like that I have a coefficient, something other than 1. So let's factor that out. Now I ask you, this 3 right here, is this going to apply to x values or y values? X values, because look, it's right, it's in the thing getting squared. So if I'm thinking about my parent function, which is x squared, that's in there with the x. It's getting squared. So that's going to apply to my x values. So if it applies to x values, what does that really mean I'm doing? I'm going to divide what? All my x values by 3. Because right now that's 3 times x, but I want to do the opposite. So I want to do divide by 3. Okay, so I'm going to take all of my x values and I'm going to divide them by 3. So let's look at what that looks like on my parent function. Start with 0, divide it by 3. Okay, you still get 0. Okay, good. This x value is at 1 right now. But if I divide it by 3, where is it? 1/3. So it moves in. Same thing's going to happen. -1 divided by 3 is now going to be at a -1/3. This x value was at 2. But now I'm going to divide it by 3. It's going to land at 2/3. So right about there. Same thing happens here. That'll land at -2/3. So, let's erase this. There we go. I have taken care of that 3. So I'll check that off. I did it. Now the other 2, luckily I can do those at the same time. That's going to be right 2 down 3. So I'll take each of these new points and go right 2 down 3, and I should be done. So my final graph . Please don't forget, when you go to take a quiz or a test or whatever, that you could check this answer, right? Take a nice point. When I plug in 2, I'm expecting to get out -3. So if I just plug in 2, positive 2, let's just see. Oh yeah, very quickly I see that I get out -3. Awesome. If you're feeling ambitious and you want to plug in one of the other weird points, you can, but I would at least check a nice point. Because it's so easy for you if you had shifted the wrong way, right? Well, you would catch yourself right there. Okay. 10. What's the parent function here? X cubed. So we'll sketch that real quick. That's not so bad. 0, 0, 1, 1, negative 1, negative 1. 2, 8 is way off my grid. Negative 2, negative 8. I'll just pop that one right there. Okay, there's the parent. And all right, 1/4 over here. What is that going to do to everything? Multiply what? I heard there was right answers and wrong answers at the same time. Multiply the y values by 1/4. Because remember, think about the parent. The parent is x cubed. So whatever is being cubed gets applied to the x values. I'm not cubing that 1/4, right? That's not getting cubed. It's not in there with the x. So that's going to apply to a y value. I'm going to take all my y values and multiply them by 1/4. Okay? So 0 stays. 1 now becomes 1/4. 8 now becomes 2, right? Negative 1 would now be negative 1/4. And the negative 8 becomes negative 2. So I now have this going on. I think I messed up a little bit right there. That should be at a negative 1/4, so like that. That's better. Okay, so I did that part. Check. And now all I have to do is go left 2, and I'm done. So, final graph. Pick a nice point, pop it in, make sure it's right. If I take negative 2 and I throw it in there, I should get out a 0. By golly, I do. Okay, last one. What time is this class on? Anybody know? 10:05? Okay, good. Ish. I don't know. We'll see how far we get. Okay. Ooh, this is a good one. So, parent function's that reciprocal function, right? Okay, so let's sketch that real quick. I have asymptotes at the axes. Yep. This one's going to go this way. And this one's going to go this way. Okay, got it. Let's look at our equation and see what in the world is going on. So, first thing I notice is that I don't have a coefficient of 1 in front of the x. So let's pull out that 2. Take out the 2, x plus 1 minus 2. Okay, so let's see, what's going to happen? That 2 is down there with the x, right? The parent function is 1 over x. So everything in my denominator is going to apply to the x's. So if I have 2 times x, what am I really doing? Dividing what by 2? The x values by 2. So all of my x values now get divided by 2. Okay, so this one, instead of being at 1, I'm going to divide that by 2. It's going to squish in here. So that's going to be my new one. Same thing here. It's going to squish in here. So it's really just going to make my arcs kind of hug even closer down here in the corner. Same thing here. You're just going to hug closer in that corner because I'm just starting off a little bit closer. Okay, so I did that part. Check. And then all I have to do is left 1, down 2. Yep, so just take what I have, go left 1, down 2, and I'm done. So I'll move the asymptotes. What did we just say? Left 1, down 2. Left 1, down 2. So my new asymptotes meet here. So my final graph, we'll do an orange, would normally be, I went out a half up one. So I'd have a dot there, so it's going to be like that. And on this side, half like that. So that orange is my final graph. Okay, we're feeling good? Yes.